Bismillahirrahmanirrahim. My name is Lubna Ahmed Merghani Saeed. My title is Classification of Fault Detection Analysis using Wi-Fi. My supervisor, she is Madame Siti Mariam. Introduction. According to the report of the World Health Organization, early fault detection is an active problem in the old age group people. In this group, elderly falling is one of the most serious life-threatening events that can occur. There are different methodological approaches are introduced for the fault detection of the basic of the deployment of the sensors, like as the cameras based or a wearable device based and ambient sensor based. To overcome this limitation, the study community has started to investigate device-free sensing technologies. Example of sensing technology, radio signals such as Wi-Fi signal are utilized to track human motion and activity. Project background, a human activity recognition is an application that senses the local environment of human being with the objective to serve the various range of the human-centric application in healthcare and smart home. The sensor data is proceeded to locally on the wearable device or transmit to the server for feature extraction, and then supervised learning algorithms are used for classification. It is commonly that elderly may fall and injure several. This problem has attacked our worldwide attention and become a major challenge in the public health care. Human activity recognition proposed the idea of using Wi-Fi-based solution for detecting system. It will enable the user not wear a device. Recently, CSI measure by Wi-Fi network is widely used for different sensing purposes. CSI-based fault detector do not need to use the users wear any device and do not invite privacy. Behavior recognition based on the CSI of Wi-Fi signal has shown it is potentially detecting fall for the elderly people. Property statement, while human activity recognition is an interesting fundamental research problem on its own, it is also become increasingly important in areas such as healthcare of elderly and sick people. Monitoring of the activity and fault detection system might mitigate some of the risk. Human activity recognition is also key component to context-aware computing for energy-efficient smart homes, fitness, tracking, and many Internet of the Things-based solutions. In addition to context of the disaster recovery case and the relevance of the fall as specific activities and the importance of the fall detection for the elderly. Due to the complex relationship between the human activity and Wi-Fi CSI measurements, the accuracy of the current recognition system are far from the satisfactory. Also, the wearable sensor-based solution, it is difficult for the old people maybe forget to wear this device. Also, the visual-based solution maybe require a good lighting and impact the privacy of the individual. The research objective, first to identify the fault detection system using Wi-Fi CSI based on deep learning techniques, to propose human activity recognition design using LSTM-RNN deep neural architecture, to evaluate the performance of the proposed system. Scope of the study for the elderly foreign cause serious threatening to their well-being and cases a major physiological harm. Human activity recognition has gained tremendous attention in recent years due to numerous applications that aim to monitor the movement and behavior of human in indoor area, like health monitor and fall detection for the elderly people. This study may aim to provide solution which prevents an elderly to be alone for an extended time after fall. Recently, Wi-Fi has been focused for much research for activity recognition. The system consists of Wi-Fi access point and one or several Wi-Fi enables device located at different part of the environment. Literature review. The evaluation of Wi-Fi, the one is essentially component of the short network wireless. The increasing available of mobile computing device has created a strong interest in one, providing far higher throughput for the far lower cost than wide area wireless sensor network. First, the development of 802.11 standard. This protocol operates in the 2.4 gigahertz channel, is the family of the IEEE. From from the wireless communication sensing, wireless mobile network has become the central network technology throughput rapid advancement of the wireless communications infrastructure that allow acknowledgement of the connectivity and collaboration everywhere and anywhere. Where-based activity recognition, the first step towards this goal is to collect the wireless signal and extract effective feature that can be used for the recognition. Channel statement information when the human move from moving within the range of the Wi-Fi network, the multipath propagation will affect. Okay, this is because the scattering of the Wi-Fi signal. To collect the CSI data between Wi-Fi and router and Wi-Fi router and laptop, we install a modification, a framework for the Intel 5300 network infrastructure card. The goal of our research is to use this CSI data to recognize human activity, and CSI has been commonly used as a predicated parameter for the many human activity implementation. Channel statement information, we have the wireless sensing application based CSI. Many research have studied wireless sensing system based on the CSI. Involved the research are the gesturing recognition, indoor human activity, and recognition and identification. We find because the main reason why such they are growing constantly are following university grain, fine grain, and healthy vivisection. The device-free sensing, the device-free Wi-Fi sensing, the most common tools is the Intel 5300, authorized CSI, and ESB 32. Deep learning is a subset of the machine. Deep learning is a subset of the machine learning that makes use of the artificial neural network with many layers of linked neurons to extract manufactured information from massive amount of the data. Each neuron at the most fundamental level use the activation function to generate an output signal from a collection of weighted input from the neurons in near pouring layer. The key to effective learning is iteratively adjusting all of this weight when the network is given more and more data sample through the training phase. The deep learning, we have many applications of deep learning. We have restrict Boltzmann machine, it auto-encoding, and multiplayer precision and recurrent neural network and convolutional neural network. Multi-layer precision is the most fundamental and also most well-known kind of the deep neural network. It is consists of the input. It is consists of the input and output and many heading layer. Recurrent neural network is a class of the artificial network where connection between nodes from direct graph logging temporal sense. This allows to exhibit temporal dynamic behavior. This anti-heading units connectivity enables the input temporal characteristic to be memorized. The CNN is a conventional neural network are used to analyze visual picture composed of rows and columns. Pixel. It anticipates working with input that reassembled to do 2D grade and have a spatial connection between them. CNN are series of the filter or to convolve the input to order to learn the spatial character. CNN learns the hierarchical representation of the data set when many layers are used. Non-short-term memory. Long short-term memory is a popular and recurrent structure and good choice for solving human activity recognition problem. It employs gate to recreate information follow in recurrent competition. LSTM network are excellent at sorting long-term memory. Depending on the data, the network may or may not save the memory. Is able to catch relationship in data on the temporal dimension without mixing the time is set up together as the convolutional neural network, CNN. Some systems have utilized the LSTM character to build fall detection system by demonstrate an efficiently integrable and privacy receiving fall detection system based on the CNN and RNN. This is related work, and they use a different method. But in my this thesis, I use LSTM and RNN. My methodology in our work, we will implement and evaluate the purpose machine learning and deep learning model using CSI Wi-Fi dataset. From the dataset, a human activity recognition design will be proposed using LSTM, RNN, deep neural architecture. The design of LSTM architecture module is outlined for the application of the human activity recognition. This study goes into the discuss on the available dataset and unique feature of each class for different axes. CSI measurement. This study adopts the CSI database. The system collects CSI as input wireless device. The background CSI is first collect the baseline data. When there are a person perform an activity, the CSI of activity and then collect for the further processing. The data set includes 7 persons and 7 activities denoted by bed, fall, pick up, run, sit down, stand up, and walk, and 20 trials for each one. Activity recognition, a deep learning model composed of RNN and LSTM would be used in this analysis to combine the multidimensional character and identify virus events. The LSTM design show many unique benefits when compared to traditional predication approaches used in activity recognition. With varying lengths, LSTM can comfortable accommodate feedback with essential since virus operation can have different time duration. The extract feature are then feed a fully connected layer from LSTM layers commonly used to prevent overfitting. The result, the experiment setup, the Wi-Fi dataset is used in this study. We have 7 activity, as mentioned before, and these 7 activity class are bed, fall, walk, back up, run, sit down, and stand. The dataset is come in the CSV file that contain feature on the 7 activity. This figure flow illustrates the sample of the dataset. The training parameter in the experiment, we have two different RNN network are used, and the performance of them is compared. This table shows the training parameter for each network for the parameter network 1 and network 2, the parameter in STM layers and dense layer and neurose layer and number of cells and learning rate, patch size, optimizer, and activation function and a number of epoch. The network 1 Wi-Fi CSI result using network 1. In the network 1, we define using the parameter described in the table above is used to train the dataset. The module verification result of loss and accuracy between training and validation, where LSTM or RNN achieves the best overall accuracy. The training accuracy and loss are shown in the figure below. This figure shows to me the accuracy for the network 1, this one for the loss, for the accuracy, and this one for the loss. We have 10 figures. This is the confusion matrix for the network 1. Is presented in this table for the 7 classes and 7 activities. This is a confusion matrix for the network 1. And Wi-Fi CSI resulting using the network 2. In the network 2, we define using also the parameter in the above described in the above table, and we predication result from the loss and accuracy between training and validation. And LSTM RNN achieves the best overall accuracy. The training accuracy and loss are shown in the figure below. Also, this figure for the network 2, for the accuracy and for the loss. And this one, the confusion matrix for the network 2 is presented in this table. We find some a little different between the confusion matrix first one, network 1 and network 2. The comparison between two networks, when comparing the result obtained from network 1 and network 2, we note that network 2 has a better performance in the network in the term of the accuracy, precision, and recall and F measure. The figure below presents the comparison between these two metrics for the two networks. From the figure, we see that network 2 has accuracy of 96.14, that is 1.54% higher than network 1. The precision and recall of network 2 are also higher, and the F measurement of network 2 is 1.87% higher than network 1. This table, this figure shows the accuracy and precision and recall and F measurement between the network 1 and network 2. Here the accuracy is 94.6 and 96.14 for the network 2, and precision 92.86, 94.66, and recall and F measurement. This is a comparison between two networks. Then I have insight of fault classification to further investigate the performance of the network 2 and distinguish between the activity of fall and any other activity. I select one activity, fall, and compare with another activity. We consider two class problem of falling against each other. The figure below shows the falling is distinguished from other activity with accuracy range between 98.78% and 99.73%. The figure below shows the training accuracy and loss of each training set. This training set in this figure show here the accuracy of the fall, comparing fall and bed. This is accuracy, and this loss for the fall and the bed. This for fall and sit down, and loss of fall and sit down, and accuracy of fall pickup, loss fall pickup, fall stand up, loss of fall stand up, accuracy of fall run, loss of fall run, accuracy of fall wake up, and fall wake up and loss. Compare one, I fixed one activity fall and compare with the another one. We find different in each one because the movement is different. From the table, we say that from this table, we see that fall and stand up has the highest accuracy because these two activities are opposite to each other, while fall and run has the lowest accuracy. The accuracy of the cases vary within the small range, 0.95%. This table illustrates the variance of the each cases. The fall run appears to highest variance, while the fall sit down has the lowest variance. Here we find the fall and stand up is for the accuracy is higher, and fall and run is the accuracy is low, and the variance is different from each other. But this different, it is very low, not too much. In this study, conclusion, in this study, design of human activity recognition system for using CSI with deep conventional network-based classifier. In particular, this necessity of signal pre-processing and feature extraction to the minimum by exploiting the learning feature of deep RNN. The proposed data will be the proposed data will be feed into the LSTM RNN model. The weight of the LSTM RNN model were trained from the confusion matrix. The overall accuracy was 94.6 for the LSTM. RNN and LSTM was used in this analysis to combine the multidimensional character and identify virus. This is my reference. And thank you.